about of piston rings. Piston rings, yes, I think you know it. It's one of the parts in the engine, and sometimes a lot of people in the, yeah, I will say in this area, they overhaul the engine, and they have after a while oil consumption. They say in the most of them, these are the piston rings. Yeah, and this I will take you maybe new minds about of piston rings and also maybe of failure. Yeah, they can be in the reconditioning area. Yeah, maybe also from the customer self. First, the main task of the piston rings, then the design and function, installation and the service, and also in this third step, I will show you some failure, maybe what we can find on the piston ring itself. Three steps or three main topics you the piston ring have it. Yeah, it's first is the sealing, the heat dispensation, and the scrubber of the oil. That means the three steps of the rings. Yeah, there are the main points, and these are important to understand because after when we speak about failure, yeah, a lot of failures came about of sealing or maybe of heat problems and also of scrubbing not enough oil from the surface from the from the liner. Then the next you see first, this is the sealing effect. You see on the top the combustion chamber with the pressure, with the burning of the fuel, and this high pressure they pull down the piston and bring the power on the crankshaft. And then you see the piston rings, the first and the second ring. And normally the piston ring have a tension, and the tension of the piston ring are contact the surface of the cylinder bore. But this tension, it's not enough to sealing the combustion area, this high pressure, down to the oil pan. That means we have a second pressure, and you see the white uh, 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 situation or the situation that the pressure will be behind the piston ring and press the piston ring to the surface, yeah, to the liner. And this effect, together with the torque, with the force of the tension of the piston ring and the tension from the combustion behind the ring together, then we have a sealing effect on the surface on the liner and the piston ring, and the pressure cannot be dropped down to the oil pan, that we don't have the blow-by effect. One question to you or one information to you, the combustion chamber, the pressure in this area, it's not every time the same. It's up in which load you drive the engine. When you drive the engine in a high load, when you climb up a hill maybe with a trailer behind you, behind the car or the truck, then the pressure will be increased. And then when the pressure increase, we have a higher pressure behind the piston ring, and the sealing effect will be also better. When you drive down on the hill, we accelerate the gas pedal or we decelerate the gas pedal, then we have less load on the combustion chamber. And then we are losing the pressure behind of the piston ring. And in this effect, we have only the tension of the piston ring self. There are contact and have the sealing effect on the liner. And in some cases, this cannot be enough. And then we have the blow-by increase. And also, we are not sealing and scrap the oil enough. That means better is for an engine when we have the combustion chamber with a higher load and higher tension behind the rings. But we cannot drive every time engine in high load. This is not it's not the life This is why in the normal situation, we must know it when we take an engine in idle speed, then the pressure is also not very high. And then we have also not the sealing effect, and we can have more blow-by. That means in this situation, when we drive or the engine is running in idle speed, this is not helpful for them. And this is the customers must also understand when they're using an engine in a long time, in a long period, the engine in idle speed without a load behind the piston rings, they can have problem in the future with this engine, oil consumption, or also other parts that I will show you later. Here you see the tension from the ring, and you see the tension only from the ring side. Yeah, they are pressed on the surface of the cylinder bore. And here in the next slide, you see the pressure come from the top and press 10 times higher what the piston rings have the tension, and 10 times more we press the ring on the surface. And this is one of the biggest point that also a driver from a truck, from a passenger car, or what is using an engine, they must understand better is an engine in higher load using, but in less load to use. The second time or second part, it's the heat dispensation. That means the heat, what we created in the combustion chamber because of the fuel burning and so on, this heat goes inside also to the piston. Some of the heat goes out to the exhaust pipe, some heat goes to the cylinder liner and goes to the water chamber, but some heat goes also to the piston, and the piston must be also cooling down. That it's important that the piston, alloy piston, are not higher with a temperature 360, but very um, I will say complicated can be when we have more than 400 degrees. That means the temperature, we must regulate the temperature on the piston, that the piston temperature will be not too high. And this is also the piston ring have the job to take the heat from the piston to the surface of the cylinder liner. And this what you see in this picture. We see the first piston ring because there is on the top very close to the piston grown. This can be 55% of the heat together from the piston rings. They can move to the cylinder surface. 55% they can take the temperature to the surface. The second ring 30% and the last 15%. This can be in some application of pistons completely different. That means in some cases we have piston with cooling channel or steel piston with double cooling channel, and then the piston rings, they have not a big job to move the temperature to the surface, to the liner, because the most of the cooling comes from the spray nozzle, from the oil spray nozzle for the cooling channel from the piston. But what you see here, the first ring have the biggest job because for about of the temperature, the second, and then the third. And this is also why we have different applications of piston rings and surfaces and material. Because when the first ring must bring more temperature to the surface of the cylinder bore, of the cylinder liner, then maybe we need other material that they will not be damaged because of the high temperature. And in the next application, maybe we can have a standard ring without any big features, and they will not damage and have failure because of the higher temperature. The next slide, you see the scrubbing of the oil of the cylinder liner. That means in this case, we must We must scrap the oil from the surface. The spray nozzle, maybe when we have a cooling channel, or all the oil what is spray from the crankshaft to the surface from the cylinder bore, we must scrap it down with the scrapper ring, and we must have round about 1 to 2 micro on the surface oil and not more, because we need also a little bit a small thickness of oil film for the second and the first ring, to have lubrication between the piston rings and the surface of the bore of the cylinder liner. And the scrap ring must be scrapped the oil down. And you see also the drainage behind the piston rings. There's a spring behind, and then you see the oil can be returned inside to the piston. And this can be also different. Each of the piston, what we created in our engineering department, can look different how we transfer the oil back to the oil pan. Not every piston have a hole between the piston, the oil scrapper ring directly to the inside of the piston. They can be also completely different. But very important is it that this drainage, this bore must be open, that the oil can be, I will say, come very easily, yeah, to this bore and inside to the piston, and can be dropped down to the oil pan. When this drainage is blocked, then we have problem. Then the oil scrapper ring will scrap the oil, but they cannot remove it back to the oil pan, because when this drainage is blocked in other parts. And this is also important when you open an engine, that you must look, is this drainage open or is there blocked? Is there something wrong? Then there is not a problem on the piston ring, there is a problem on a different part. Design and features or functions. Here you see a piston, it's running up and down, and then we have the clearance between the cylinder bore and the piston. And this clearance, this is take also the piston to the left and to the right side up to the angle of the crankshaft and the conrod on the piston. You see it now, the piston, it's moved on the right side, and then when we go on the top, he switch over to the left side. And then this we have one, it's the thrust side and the under-thrust side, the anti-thrust side. Now we came in this situation, the piston goes up, and then you see in the biggest draw on the top of the drawing, the pressure. And then when we are very close to the top dead center, we fill up the fuel inside, and then you see the piston, it's jumped to the left side, to the thrust side. And then we have a lot of stress on the skirt of the piston. Also, we have stress on the cylinder bore, yeah? And also we have very high contact with the piston ring on the left side. And then we move it to the right side and anti-thrust side. And this is also moving the piston rings inside in the ring groove from the piston and moved outside, because we have a little bit clearance in the bore from the piston. Here you see the first, the second compression rings and the oil scrapper ring or oil control ring. We will concentrate first for the first and second compression rings. Here you see the rectangular ring. That means we have every place is the same angle. Then we have a single side keystone ring and a double keystone ring. The biggest problem is in the first ring groove, when we have no load on the engine, what I said before, we have no pressure behind the piston rings. Then also the pressure from the piston ring to the surface of the cylinder surface will be less, and cannot sealing and cannot scrap the rest of the oil down. And then that means all come to the combustion area, burn, and then we build up carbon. When oil is burned, it's too hot, then we have built up the carbon. And in this situation, the carbon will be not only on the piston ground, they will also build up in the first ring groove from the first piston rings. And when there are carbon inside, the piston ring cannot moving. This is also very important. Each of the piston ring must move in the ring groove, in the piston ring groove from the piston. Or when they are moving, it's stopped. Then we have problem. You remember when I show you this movie, when the piston goes up and down, and then we have a thrust and the anti-thrust side. That means we have only on the left skirt and the right skirt, yeah, there we have pressure on the ring. And this area, in this line, there are the piston pin. We don't have contact directly. There's not a pressure and anti-pressure side. And this is when the piston goes up and down and have only contact left and right, then we have wear only on these two places. And this is why the piston ring must be moved completely every time, turn around in the ring groove, that the wear will be in each position the same. And then we can sealing. And this is when we build up carbon inside, then the ring cannot moving. And this is why on diesel applications, we using this keystone ring, because the keystone ring also, when we have a keystone ring on a piston and this engine is not running in very high load, they will also have this problem, build up the carbon. And where in this sorry, in this situation, when the carbon is built up between this clearance from the piston ring to the piston ring groove, they will block. The keystone ring have one positive point. When we moving the piston to the left and the right side, what we saw it in the movie, one time it's a piston ring inside in the ring groove, and the next time when the piston goes to the left, the piston ring will be jumped out, and then the clearance will be bigger. And then they can clean up this carbon, they can break down the carbon, and then the carbon goes up to the combustion area, and blows out on the exhaust pipe. One example, I was in Finland and then we visited a customer, and this was a very big engine. The engine size was, or the piston size was around about 55 centimeter. And this engine runs in a hospital every time in idle speed, because when something wrong with the electricity, they must bring very quick the power to each of the place in the hospital. And this is why they run in idle speed. But in this situation, in idle speed, what I said, we're sealing not perfectly the ring. And in this situation, they build up carbon. And in the first ring groove was a lot of carbon inside. And this customer asked me, "Oh, Rainer, what we can do it?" I say, "Sorry, yeah, maybe you can pull up this engine sometimes in a high load condition, that the carbon will be not be there, or you must using maybe a double T keystone ring, yeah, what we see here in the picture, because in this engine was not a keystone ring inside, it was a very old engine. But this is why in the new applications we find this keystone ring, they can break down or break out the carbon, and then the moving of the piston rings, yeah, will be safe. On the next slide, you see this is an application from the petrol engine. And then you see also in the top and the first ring, we don't have a keystone ring inside. This engine, they don't have problems with carbon. On the right side, this is a diesel engine. In this application, you will find a keystone ring and also a ring carrier. to save the ring groove in the piston, because the pressure is higher, the temperature is different. But this is not be the last information for you. The last information for you, in the passenger car, or in the petrol car, sorry, in the petrol car, we will have also a keystone ring inside, a ring carrier inside. And in some cases, you will also find a ring carrier and a keystone ring, because the newer application of the petrol engine, passenger car with direct injection system, they have also a particle filter inside. And they have also this problem, what we have also in the diesel engine, and can be built up this carbon on this area. Standard in the newer application, it's the ring carrier, and in some cases you can find also a keystone ring, but not so often. Then to the next slide. Here you see the sliding surface of the compression rings, cylindrical or crowned. And you see the surface, there are contact on the cylinder surface, can cylindrical or crowned. The difference is, when we have a crowned ring, then we have a point contact. That means a point contact on each of this crowned position. We have a contact up to the position with the surface, or a small line contact. On the cylindrical, we have a very big area, the completely area are contact with the surface. And up to the pressure was behind of the piston ring, then we have less pressure, and less pressure give me the information, less sealing effect. And this is why a crown compression ring have a better sealing contact, sealing effect from the first second in the life of the engine. Here you see also the compression ring with a scrubber off effect. That means we have a cylindrical ring and a neighbor rings. Then you see we have on the outside, we have a step that give also this ring a better contact, and also a little bit better or more sealing or scrapping of the oil. And this can be, maybe this ring you can find maybe in an engine. There are not stay inside in this truck or in this train or in each of the passenger car. Maybe this engine is lying on in the floor. The most of them, maybe we have find this in some applications on the train, and then will be maybe better that we have enable rings. We have also here a taper phase ring. We have 40-60 grad roundabout. In the past, all of the reconditioner, they say this is a minor ring. And this effect have, when we have start the engine after we overhaul it, a small contact on the bottom of this taper phase ring have directly contact with the surface. And this surface, or this small contact area behind, and also from the pressure behind the ring, pull and press the ring very high, with a high pressure, with a high tension to the surface of the cylinder line surface, and have a very good sealing effect. And also on each of the piston rings, up, have nothing to do which kind of ring. They need a little bit a running in effect. And this running in effect needs time. The time will be less for this running in effect, or when this running in time it's over, will be quicker when the engine using it with higher load, because when we have higher load, we have higher pressure between the piston rings, and we have a higher contact with piston rings and the surface. And then this wear what we will have will be more, and then we have a quicker, I will say, running in effect, that when we have in less load. But in the older versions, there are the surface, the honing process will be not so perfectly because the machine was not there in the past 1965 or 60. Then we have a line contact, and this line contact with this taper phase ring, we have a high pressure, and this high pressure have much more wear, and this running in effect will be much more better in this case. And you will also find in some cases, in some engines, we have this taper phase ring again. But in the normal situation, we can create the surface, the honing process on the cylinder bore better, and then we don't need this running in effect what we had in the past. These taper phase neighbor rings, you see on the bottom side, this is a very aggressive ring. That means when they come from the top 10 center to the bottom 10 center, they scrap the oil very, very strong from the surface, and then we have the rest of the oil for the piston rings. When you take these piston rings in the wrong situation, maybe you will turn it to 180 degrees, and then the neighbor phase will be on the top, then you will pull up the oil directly to the combustion chamber. This is very important. All of this ring must be in the right position, and this is also why the piston rings have the mark with top on the piston rings. And then we see the taper phase neighbor rings with closed gap. That means in the end of the ring, there are closed that the oil can be not jumped up on this clearance of the piston rings and can go up to the combustion area. Here you see on the next slide the two pieces or one pieces and two pieces of oil ring, control ring, the oil scrubber ring. Here this is a very older or the older version without any expander spring. This is 1965. A lot of Deutz engines have it, and some of this piston they're using this kind of oil scrubber ring. They have not only one scrubber ring, they have maybe two scrubber rings inside, because we can only control the tension from the oil scrubber ring. There are contact with the surface in the construction, and this is only how we producing this ring. We can take the pressure or the yeah the power from the ring itself. Here, this is the next one. This is the most application on the diesel engine, a ring with the expander spring, and now the spring will be bring the force, the power from the ring, how strong it's the ring, have contact with the surface and can scrap the oil down. And the spring can be with higher tension or less tension. This application, it's the application what you will find in the petrol car. And this it's completely different in the construction. We have two small shims on the top and in the bottom side, and behind these two shims, they are very, very small. We have this special spring, and with this nose on the spring, they press to the surface the top and these two shims, I would say shims to the surface and scrap the oil down. This ring we will be using in the passenger car because this ring can follow very good tension and other things in the engine. When the engine will have stress because of the power, then the piston and the cylinder bore will be maybe not exactly round, and then a scrubber ring, they cannot follow this moving of this engine, this torque and stress in the engine. Then we have in this application, we can have oil consumption, And this is why we're using in the most of the passenger car, the aluminum engines, we have this special three pieces oil scrubber ring, oil control ring inside. Here you see also the radial pressure of a piston ring from a two pieces or three pieces oil ring, and you see the tension will be round on the ring and every place is the same. But when we look on the compression ring, the first and second ring, then you see the pressure is on the open side of the piston rings will be higher. And this is also when you open an engine after a while, maybe there runs, I will say, 100 hours or no longer, and you open it again, then you will see on this end of the piston rings, there are the pressure higher, you see the wear, but on the other side of the ring, maybe you don't see wear positions. And this is also when we don't have a line outside on the surface of the piston rings completely around, this will give me information that the piston ring, this running in time, it's not finished. We must have a small line outside on the surface of the piston rings. They have contact, yeah, on the piston ring, and then you see a small wear line. This is not very big, but shining more, yeah, when you show with your eyes on it. And this gives me the information, yes, the running in effect was finished on this engine, or they must run maybe longer. And again, when you start the engine, better to do it in a higher load position than in a less load position. And this is also information that you must give to the end user, to the user that is using this engine, this truck, this passenger car. They must take this engine a little bit more, maybe in load position, that the engine will be run very quick for this running in effect. The piston ring joint clearance, we need it because also what we saw it before, we saw that we have temperature on the piston and the temperature goes to the piston ring, and also this piston ring will be grow up a little bit because of the temperature. And this is why we need clearance on the piston rings that they will not blocked. When the clearance are too small, and the temperature maybe it's very high, then can be, when we don't have the clearance, the right clearance, can be blocked the ring there, and then they will take in a spring form. And you see, then the ring will be can be not move in the ring groove, and then will block, and then we have the next problem. And this is why we need this piston ring joint clearance. Exactly what maybe you saw it in the past, I will say 8-10 years ago. In the past, we had 10 years ago, we had from the first and the second ring the same piston ring joint clearance. But then they changed it round about for 10 years, and then we make on the second ring a little bit of bigger joint clearance to 1 up to 2 millimeter. And normally we have 0.5, 0.7 maybe. It's the normal standard joint clearance. Because why we do it on the second ring groove, a bigger clearance, that the pressure from the first ring, this is what you see it on the second picture. There you see the two lines from the top, the pressure can drop down, go behind the ring, go in the ring inside, yeah, and then the pressure, yeah, comes from the first ring, yeah, down to the second ring. And that means only this small window, this red area, this red line, what you see on Y and X, and this area, the pressure can be dropped down and go down, yeah, to the next piston rings. And then they go inside exactly on this area from the second ring in this piston ring joint clearance. And when this window is bigger, the pressure can be go quicker behind the second ring and can press quicker with the high pressure the ring to the surface. And we can sealing perfectly, and also the pressure can be dropped out again, yeah, when the clearance a little bit bigger. And also the blow by reduction during low load operation also. You see 0.2, 0.5 first string, maybe in some cases also to 0.7. Second ring, 1 to 2, and the third ring round about to 0.2 to 0.5 is normally the standard clearance, but can be a little bit different up to each of the engine. The coating and the wear protection. You see, we can have also different surfaces on the outside of the ring. The coating, this can be a phosphate coating, yeah. It's good for corrosion, or maybe we have a molybdenum coated ring. It's perfectly when the piston ring must be moved a lot of temperature from the piston to the surface of the bore, then the temperature will be higher. And this is also when we have a molybdenum ring, they can be better work with higher temperature, because the material molybdenum, you can use it with a higher temperature. And also when maybe it's sometimes missing a little bit oil, yeah, can be also I will say safety or emergency, yeah, situation. The molybdenum can be, yeah, safe maybe for small oil missing, yeah, for a small time. Then we have the PVD coated minimum wear, maximum durability, and less friction. And this is the most of the ring will find with a PVD, or what I will show you the next slide with another ring, yeah? Because everybody speak about minimal wear, yeah? Less friction. And the less friction, then we need the PVD coating, the chrome ceramic coating, or the, yeah, with diamond coated. But this kind of ring, it's the most expensive ring. Yeah. And this is, but it's very good. Minimum wear, less friction, maximum durability. Chrome layer with network, and you see also the micro diamonds. We put it a small particle of diamonds inside, and then the ring will be, yeah, very hard and very, you can use this ring for a very long time. We will come to the installation and service. This is what I said. We must look that the piston ring can move in the piston ring groove. This is also, you will find a video how you can install, yeah, a piston ring in a piston. Normally, you know it better than me. Yeah, have much more often a piston and piston ring in the hand than myself. But maybe for a new colleague in your company, yeah, it can be helpful. Maybe if, you can find this movie, and you can also download this movie on our website. When when you will overhaul an engine, and then you see a engine, yeah, they have maybe a little bit wear, what you see on the right side on the cylinder, and then you see there's a piston, they have a lot of carbon build up on the top, what also I spoke before. And maybe the customer say, or the end user say, it's very, very expensive. I will not have a new piston. I will not have a new liner, I will only have a piston ring. Yeah, but this will maybe not be helpful because this is not the right overhauling. The problem will be when you only change one part, yeah, you will not sure, yeah, the engine will be not have oil consumption, other problems, blow by and other things. Yeah. This is why we say, yeah, you must check everything. Yeah. And in the most of the application, in the most of the situation, you must overhaul the engine with a piston ring, with a piston, and you must look also of the surface of the cylinder bore. And all these three parts together, yeah, then we will make a good job, but not only one part. This is the same situation when my shoe is broken and then I say, okay, my right shoe is broken. I will buy a new one on the right side, but the left it's too expensive. And I have on the left side my old one and the right side a new one. Then it will be not good for my body. Yeah? And I will maybe have problems with my back and other things. And this is the same in the overhauling engine. You must look what makes sense, yeah, and you must give to the end user the information why you must spend maybe more money, yeah, to overhaul this engine and make it on the right performance that the customer will be not have problem in the future. This is also why you must look that, hold on, you must check the old piston when you clean it up. Yeah, and when you clean it up, then you must look how it's the piston ring groove, the clearance. Is it too much or not? Or not? Is it necessary to change also the piston, or it's enough to change only the piston rings? Here you see, after a while, after maybe I don't know how many miles, kilometer, yeah, the ring will be have wear inside in the ring groove because the ring groove in the piston will be have the wear. And in this situation, maybe the pressure can be not jumped in inside or behind the piston rings, and also the piston ring, yeah, it's twisting a little bit more. In this situation, you see when the piston, yeah, on the right picture now, the piston goes up and down, and then the compression cycle, the oil is pushed upwards by the piston rings. When the piston goes down, they bring the oil down. But when the wear is too big, then the oil can be removed or can be come behind the piston rings, and then they can come jumped up to the combustion side. And this is why you must check how it's the wear on this area. This is what we say in the aftermarket round about the clearance 0.05 on the first will be okay. 0.11 to 0.1.2 will be critical. In some applications, we can have oil consumption. And when it's higher than 0.12 millimeter, this is too much. And then we have definitely oil consumption because of this one of the piston. The problem is the first ring, the keystone ring, you cannot measure it because it's up to the position, how strong you press the ring inside in the groove, then the clearance will be less. You can only check it visually with your eyes, how looks this area. There are the keystone ring have contact. We have on the right side, you see, we have a special bowl. Each piston rings, it's different on the diameter and on the height. And then we have a special bolt for each of the ring, and we pull this bowl inside, and then we measure how wide it's the bowl stay out of the surface of the piston. And then we see it's this area, this angle correct or not. But you can only do it with your physical, with your eyes. This is the problem, I will say, every 3 months. Yeah, I have a phone call from reconditioner or private people, because when a piston or engine is running, and after a while, after 100,000, 200,000 miles or more on the truck application, we will have wear on the top of the liner on the surface. And exactly in this area, there we have this wear on the top and center. This is exactly the position the piston ring stopped for a microsecond, and then the piston goes to the bottom dead center. And exactly in this position, where the piston will be go up, and then they change the moving and will be go and go down. And this situation, for a micro of second, the piston ring it's stopping. And when the piston ring it stops and will not moving, then they will be exactly on this area. We have the highest pressure behind the ring because of the combustion pressure. And when we have the highest pressure behind the ring and the ring it's not moving, then the ring it's pressed this oil film. That's what I said before, this 1 to 2 micros. They press this oil film completely down, and then the piston rings have directly contact, metal of metal, on the surface of the cylinder bore. And exactly in this position, we have don't oil between there. And when then the piston ring moving again down to the bottom center, in this area, we have in for a very small time, we have don't oil between the piston rings and the liner, and we have no oil there, and then we have much more wear. And this is exactly the point. There you can see, is it necessary to change the cylinder bore or drill it out to the oversize or other things? The biggest problem is when you see there is wear. Passenger car, we say 0.1 millimeter. This is maximum, and then the light vehicle or the heavy duty engines, 0.15 millimeter. But when you say, it's not so much, I will only change the piston and piston rings, and then will be okay. Or maybe you go with your hand honing machine a little bit down, up and down, and say, now I will refresh a little bit the cylinder bore. This will be not helpful, because the problem is, this is the situation, what you see it in the picture on the old version. The using piston ring, and also this surface, this bore with this problem, with this step, I will say, in the cylinder surface. But when you do once, when you change only the piston and the piston rings, we have don't this space between there, and then the piston ring will have contact on this step on the surface. And when the piston ring have contact, then they will lose the pressure, because they will have a vibration. In this situation, we have the problem when they have no tension and will not sealing, then the oil can jump very easily up to the combustion area. And then we speak about a fuel consumption. And I would say once or twice in the year, a recondition called me and say, oh, Mr. Holwein, I know I have a problem. I saw this engine have a little bit worn there, and then I I think it's enough to change only the piston and the piston rings. And then was exactly what you see in the right picture of the slide, the situation. And they open again the engine, they drill it out, make oversized piston inside, or change the liner up to which kind of engine is it, and then the oil consumption will be not more there. And this you must also maybe in some cases describe to the end user, to the customer. This is what I said before. Up to the piston rings, up to the application, is it necessary that the piston ring are in the right position. That will be top. When there is written there top, they must be on the top and not on the other side. Also, some of the piston rings, when you are removing or you're changing the piston rings, you must check how you maybe deform the ring when you don't have the right tools to disassembling the piston ring. When you do it maybe with your finger and you do it what you see on the drawing on the left side, you will bending the piston ring, and when there is incorrect in line and you have a step inside, then they will not be turned in the on the ring groove. And when we don't turn the ring in the ring groove, we will have wear on the left and right side of the skirt of the piston, but not on the other position. And then we have not a sealing effect. The most problem will be on the next slide, what you see when we over tension the ring. When we take the ring too much, when we will take it inside in the piston, and then you see it on the picture self, they will be not sealed, and they will be not sealed maybe after 50,000 kilometers, and not will be sealed in 100,000 kilometers. They will start from the first second with oil consumption, and everybody think, oh, I have the oil consumption. And maybe there was not using the right tools to assembling the piston rings. And here you see we have the piston ring tools there to installation the piston rings. And you see the first tool with these two blue handle parts. It's using 50 to 110, 110 to 160 millimeters. This is our truck application. And then when you have a truck maybe with more than 140 millimeter, then maybe you can also use this other tool, what you see on the bottom side. This can be also okay, but don't using this tool what you see on the bottom side for smaller piston rings smaller than 140 millimeter. Because when you're using this, then you will have exactly this problem what you see it here again. You will over tension this, and the other tools, they will bring the tension completely around on the piston ring, and then we will not deform it. When you installation the oil scrubber ring with this expander spring behind, you must look that the open position of the piston ring and the spring end must be not in the same position, because when you take it on the wrong position, the open position of the spring to the open position of the piston rings, then can be also maybe block the piston ring, the scrubber ring, and they cannot move in the piston groove self. And this is why important that you installation the spring right. Before or when you buy a piston by us, you take it out of the box of the carton. Then you must also check it how it stay the springs behind it. You see it with your eyes normally. They say the same is on the three-part oil scrubber ring, on the oil control ring, that the spring must be behind, also in the right position. In some cases, we have a color on the end, blue and red or black and white, I don't know. Or in some also, there is not a color there, then you must check it's the spring are not overlapped together. When they have not in this position, we will not bring the pressure behind these shims, and then we cannot scrap the oil perfectly. Here you see on the top, on the right side, when there's this overlapping the spiral ends of this spring, then we will not have the pressure there. And also on the right side, on the second picture, you see there is one of this nose is broken, and this comes when the spring are overlapping in the position when you install it. This is why it's very, very important to check it before you take the piston inside in this engine block in the bore. Yes, also to check there are moving the rings in the ring groove, and also to take the open position, the ring joint end, on different places when you installation the piston inside in the engine, because then the pressure from the combustion side can be not dropped down to the oil pan for the first, I would say, second when you start the engine. After this engine is running, the ring is moving, and you don't know in which position is the open point of the end of the piston rings. They can be in different places, but in the first step to start the engine easily, to take the ring joint ends on different places.